Hi everyone, Professor Scritch here. Welcome to our second lecture.
Today's topic is neuroimaging, the different techniques psychologists use to understand what the brain is doing to allow us to think and learn. Today's short lecture is based on this wonderful commission I got from the artist Hornbuckle. Here, Professor Scritch and Dr. Erlenmeyer are performing a cognitive neuroscience experiment. Want to learn more? When we think, brain cells, called neurons, are communicating with one another through a mixture of chemical and electrical signals. By measuring these signals, doctors Scritch and Erlenmeyer can better understand how the brain produces complex thoughts, feelings, and behaviors. Specifically, they're using a non-invasive technique called electroencephalography, or EEG, which can measure tiny voltage changes that make their way to the scalp as millions of neurons fire. Here you can see Dr. Erlenmeyer wearing the electrode cap that measures these voltage changes. When a stimulus, such as the picture of cheese, is presented over and over again, these voltage changes can be averaged together, creating an event-related potential, or ERP. Averaging generates a waveform with positive and negative deflections that correspond to specific cognitive functions. For example, the P3 is a positive deflection that occurs about 300 milliseconds after stimulus presentation and relates to one's evaluation of that stimulus. The ERN, or event-related negativity, is another ERP component and can be thought of as the "oh heck" response that occurs when someone recognizes that they just made a mistake. The size and timing of ERP components can reveal which cognitive processes are important for a task and how people differ in their approach to a task. EEG is an older neuroimaging technique and can't localize brain activity very well. That is, it can't tell very well where brain activity is occurring in the brain, but it can provide exquisite timing information about the brain's response, and it's relatively cheap, making it a very popular technique still today. Newer technologies include magnetic resonance imaging, or MRI. Functional MRI scans use very powerful magnets and the fact that your blood contains iron to measure how blood is flowing to different areas of your brain as you think. Unlike EEG, this is a much better technique for figuring out where in the brain activity is occurring. But EEG is still much better in terms of indicating when brain activity is happening. There are trade-offs to consider when using different neuroimaging techniques. EEG and functional MRI are just two of a growing number of techniques used to understand the brain. EEG measures electrical changes that result from the communication of neurons, while functional MRI measures blood flow, since firing neurons need more energy and thus more blood. These techniques allow psychologists to understand better how the brain produces thoughts, feelings, and behaviors in response to the ever-changing world around us. If you have any questions, please feel free to contact me, Professor Scritch, using the email address professorscritch@gmail.com.